we would like to acknowledge the traditional custodians of the land from which we're broadcasting. That's the Whadjuk people of the Noongar Nation. And we'd like to pay respects to their elders, past, present, and emerging, and extend that acknowledgement and welcome to Aboriginal and Torres Strait Islanders joining us today. And if you'd also like to put into the chat acknowledgement of the Aboriginal and Torres Strait Islanders of the lands from which you are sitting, that would be great as well. We have three very good presenters with us today. We've got Dr. Chris Harris, Dr. Maciej Sajtowski, and Dr. Pascal Elahi, who will be talking about the Merit Allocation Training 2022. And with that, I'll hand it over to you, Pascal.
Yes, so hello, everybody. So we'll be presenting the Merit Allocation Training, and we're going through the capital refresh, what's updated at Pawsey, specifically the Setonix supercomputer, and how that might impact how you request time and how you think about the amount of time that you're going to request. We'll go over the accounting model so that you obviously have a clear idea of what you're going to request and what that means for actually running the jobs you want to run, specific merit allocations, and then we'll go through how to apply. Now, Pawsey has gone through a large amount of updates. So the capital refresh overview, we're going to talk about the computational capability, which is a big deal for people asking for merit because you want to know how much you can ask for and what has changed, and also the timeline of availability, because it is going to be a transition year at Pawsey. So the capital refresh, right? So there's been actually several procurements that have been completed and a few that are ongoing. The examples of completed procurements have been Garwa, the compute cluster. There's been additions to the astronomy high-speed storage, and there's been NCMAS, the cloud compute. But the next upcoming big changes have been Setonix and Acacia, which we'll go through in more detail. So there's the Acacia object storage system that is in the process of being installed. And Setonix, their new supercomputer that is essentially en route. Phase 1 is on its way. Phase 2 will be later in next year. The first phase will be CPU-based compute. And then phase 2 will increase the amount of computational capacity in CPUs, but also add a large amount of computational capacity via GPUs. Now, what does that mean in terms of increase of computational capacity? So it's going to be a significant increase, and that will obviously reflect in the amount that you can ask for in all the merit allocation schemes. To give you context, Magnus, if you looked at the double precision floating point operations per second, or flops, Magnus would be able to do 1.1 petaflops, but Setonix phase 1, just that first initial CPU compute, will provide 2.7 petaflops. And then with the additional CPU and the GPU compute, Setonix phase 2, that's the full Setonix system, will have 50 petaflops of compute. And now the merit allocations will not be bound to specific partitions, and we will support large-scale jobs that want to run on almost all the Setonix machines. So I don't think you are limited in some sense. You could try to maybe access a 50 petaplot system and run something very large. Now the timeline, right? So Setonix full capacity will be available to researchers in 2023 and in those allocation schemes. But because it's coming online and we'll be adding compute, that'll impact the merit allocation that is available in the upcoming year. And this is the rough Setonix phase timeline, where we are expecting to provide CPU compute, so that 2.7 petaflops of compute will be available for essentially the merit allocation schemes that are coming. And that will be principally, there'll be a first half request, because in the second half of the year, we expect phase 2 to be delivered. So the first half request will have an allocation based on half a year, but then there'll be additional, obviously, allocations. You'll have a second allocation that you'll put in a request for, where the amount available has been increased. There'll be also, not this year, but next year, early adoption calls for the GPU partition, so Setonix early science calls. And then obviously for 2023, once the system is fully up and running, we'll have merit allocation schemes reflecting that when we put in requests in 2022, in the latter half of 2022. Now, what does that mean for you? So Setonix is a new supercomputer. Setonix is the scientific name for the quokka, which is why we have quokkas everywhere in our presentations and in our themes. There'll be a change in the hardware, and that will require you to maybe think about your requests. I'll go over those changes point out the key ones, and also go over the software changes and how that might impact your allocations, your request for allocations. So Setonix in phase 1 is going to be a CPU only system that will provide CPU compute. It'll have a very fast interconnect. It'll have high memory and visualization nodes. So you can see that there's 500 compute nodes, but there's also going to be 8 very high memory nodes. So that's terabyte memory. So if you're looking at jobs that really do have memory requirements, they should be fulfilled in phase 1. And then phase 2 will add additional compute and production level GPU compute, and it'll increase the speed of the interconnect. So we'll have a very fast interconnect for Setonix and between the CPU systems and the file systems. And in this diagram, I would like to point out we do have file systems that you'd be somewhat familiar with. So home/home, there'll be /scratch, so that's where you're going to do all your work. It's going to be very fast. There's about 3 petabytes of really fast Scratch and 12 petabytes of less fast, but still very fast Scratch. But there's a new system involved in this supercomputing ecosystem, which is called Allocation, and Allocation is going to provide the large volume storage. So it's going to provide large volume storage through something called Ceph, and you'll only be able to interact with that through an S3 interface. For people who ever had to use AWS, that's the S3 interface that I'm mentioning. There'll be further presentations further on the line, really introducing in detail Allocation. So this is just to get a sense that there will be a project storage that is different from what you're used to. So the key hardware changes going forward is we're moving from Magnus Intel nodes, which have 24 cores, to AMD nodes, which have 128 cores per node. So that's quite a technology change and an increase in the core count per node. There's a lot more compute per node. And we're also going to more memory per node. So it's going from 64 gigs on Magnus to 256 gigs on Setonix. And that does mean that there's a slight change in the amount of memory per core. That probably wouldn't be, if you're looking at detailed calculations of what you want, that might impact you because you're going from 2.5 gigabytes per core to 2 gigabytes per core, but there's a lot more cores available per node and there's a lot more memories. You can fit a lot more of a job on a node. The change that will be quite significant is, and we'll go over this in detail. Can I ask whoever's not muted to mute themselves? Okay, thank you. So we're going to be moving from exclusive node access to shared node access. There'll be more slides talking about it in detail, but the exclusive node access is how you access Magnus. You ask for resources and it's given on a node by node basis. And that will not be the same on Setonix. The other big change will be, for those who are familiar with the Magnus systems, we're using /group to kind of house lots of material, lots of data. That will be moved now to the Allocation object storage system. And there'll be also changes in where software lives, going from /group to /software. So there are some subtle changes. The big one that probably you need to maybe think about, because it will impact how you handle data, is the fact that group will no longer exist. So the upcoming system will have home that will behave like home as it is on Magnus. There'll be a /software where we're going to place all the software that you would use on Magnus, but also where you would place software as a project, as a group. Scratch is Scratch, fast workflow storage. You run jobs there, you write jobs to it. But the main thing will be Allocation, which is we're going to house the large volumes project storage. So if you need to have large files and then interact with them, the idea is you're going to have to interact with Allocation and move data in and out of Allocation. And no longer will that be available on group. The software overview and the changes there, I won't go into all the details, but I provided this slide so that you can have a look when you want to look at these slides to see if one of your favorite supported software is there. As like Magnus, Cray is going to provide optimized libraries, compilers, and tools. And somewhat like Magnus, Pawsey is going to support a bunch of software. So we will provide a lot of software for people to use through modules, load up and run. There's a bunch that are popular that won't change. There might be a slight change in the list, so it's a good idea to see what the supported software is. But the main thing is the change from Intel architecture to AMD, which means that there'll be no more Intel compilers. For those of you who are used to building your own codes and saying that we ran with Intel and this is our performance, now this is going to change, and you'll Going forward, it'll be AMD and AMD optimized compilers. There'll be a change from OpenACC to OpenMP, and there'll be a subtle change of how we manage software. Our package manager that we had in-house, Mali, is now moving to a more fully fleshed out multi-institution supported tool called Stack for managing software. And those are the key changes for software and hardware to consider when you're looking at trying to write your proposals. I will now move on, let Chris take over to talk about the accounting model.
Thanks, Pascal. So in this next section, we'll be covering the accounting model for Setonix, and we'll also briefly discuss what we currently have on Magnus first, just to talk through the changes as we move from one to the other. And then we'll provide a couple of examples and sort of provide some contrast with the accounting model that I understand is being used on Guardi. What are we talking about when we talk about the accounting model? What we mean is how we charge for time on the supercomputer. So as part of the merit allocation process, you'll typically in your application be putting forward a justification for the amount of compute time that you need based on the science and the workflows that you need to run. And we have traditionally asked for this in core hours, but as we are going to be transitioning in the second phase the following year to a GPU system, we're adopting the term service unit because we'll need that for comparing the GPU nodes when we get there. But for now, the service unit, one of the really key things to keep in mind on Pawsey's Setonix system, a service unit is equivalent to a core hour. And we've made that decision to try and make it as intuitive as possible. So you can use these terms interchangeably when applying for time on Setonix. So what do we mean, for those of you that might not be as familiar with core hours? To determine the cost of the job, you're multiplying the number of cores that you're using by the number of hours that the job is running for, and that gives you this unit of core hours. So we see in the examples here, 1 SU or 1 core hour is equivalent to using 1 core for an hour, or for half an hour using 2 CPU cores. So you kind of get these shapes of jobs and the charge. The other example here, for 24 hours on 1 Magnus node, which had 24 CPU cores, you multiply those out to get your 576 SU. And that same SU on a Setonix node, because it has 128 cores, will get you 4.5 hours. So on the next slide, we can look at the current accounting model on Magnus. So on Magnus, we have an exclusive use of nodes. So even if you're using part of a node, and we can see in the diagram there, we haven't put all the cores, we've just sort of put 6 on there to make it easier to interpret what's happening. You can see in this example, the code is using the 3 cores highlighted in yellow. So only half of the cores on the node, and there's a number of reasons why you might do that. It might be that you're saturating the memory bandwidth and the code actually runs faster when you're only using 3 of the cores, for example. But because you're making use of the full node and that node is unavailable for anyone else to use, we charge for the full number of cores on the node. So whenever you're using a node on Magnus, you're getting charged for the full 24 cores on the node. I think we can now move to the next slide. So for Setonix, we're taking a very similar approach. But one of the things that we currently have with the setup at Pawsey is not only Magnus, but other systems. So we also have, for example, Zeus, which is used for pre and post processing jobs that may not require a full node to do things like setting up meshes or doing sort of file preparation or post preparation before you move files off. And so it may be very inefficient to use a whole node to do that. So as we're moving to Setonix, we're wanting to have sort of one system where all parts of the workflow are running. And so we are moving to having this ability to use a portion of a node for these smaller sort of pre and post processing jobs. So in this example, you can see that the job is using 3 of the cores, but is also using 2/3 of the memory. And so it's using a portion of the node. And this means that you'll only be charged for the portion of the node that you're using. So if we move on to the next slide, I think we have a couple of examples that we can look at. And a node has more to it than just the cores. You also have the associated memory on the node and the memory bandwidth. And so we've tried to take an approach of having as simple a possible model to capture the fact that you may be using more of the node than just the cores that you're requesting. So in the example on the left, the memory allocation that you're using is 2/3 of the nodes, and you're only using half of the cores. Will be charging for that job for the larger amount, because someone else wanting to use this node and run only really has full availability of those remaining 2 cores, because the RAM associated with the core that's not being used has been consumed by the existing job. And on the right-hand side, we can see that this particular job is using 2/3 of the cores, but only a smaller portion of the RAM. And again, we're charging for the larger fractional amount. So whatever the largest amount of the node that you're using, that's what you'll be charged for. It's also worth noting that it is completely, I guess, optional to make use of the portional usage of the node. Like if you really want to make sure that no one else is running on the nodes that you've been allocated, you can request full nodes and be charged for full nodes. And so this is, I guess, additional flexibility that's being provided, but it shouldn't be impacting on the work that's running on the system. So just to touch on potential differences, I understand some of the researchers that I've been talking to wanted us to be very clear about the definition of SU. I understand in the past year that on Gaudi, the definition of SU is actually 2 service units for 1 hour of using a core on the system. So just be aware that there may be differences between the system, and we just want to be very clear that 1 SU is equal to 1 4-hour Setonix. So if there's 128 cores, 64 cores and 2 processors to get that 128, and 1 SU is equal to 1 4-hour. So I think that's all I have for that section, and I'll pass over to my colleague Marche to continue with the merit allocation schemes.
Thanks, Chris. So yeah, I'll cover a couple of slides related to merit allocation schemes, and then we'll jump into the how to apply section. So in the merit allocation schemes, I will be covering the merit allocation schemes available for Setonix in 2022. A bit of discussion about the timeline. Both schemes that will be available for Setonix are the codes for those schemes are already open, but we'll discuss a couple of things around that, and then jump into discussion about the GPU resources that Setonix will bring. So on the next slide, I wanted to introduce the merit allocation schemes available on Setonix. So we have the National Computational Merit Allocation Schemes, also known as NCMAS, which is an annual allocation call open to all Australian researchers. This particular scheme is operated by NCMAS Secretariat, and the resources available in this scheme are for 3 systems, one located at Pawsey Setonix, Gaudi system at NCI, and as well as the third system, Massive, available through that scheme as well. The Pawsey Partner Merit Allocation Scheme is available for Pawsey Partner institutions, which are currently CSIRO and four Western Australia universities, as well as the WA government institutions that are involved in research projects. It's also an annual call, which is already open, and in both cases, the applications that are submitted to those calls go through both technical and scientific assessment, meritorious assessment. One thing to note here is that some of you might have been aware that in previous years we have been operating an energy and resources merit allocation scheme, which will be discontinued in 2022. And from 2022, researchers from the Australian energy resources research community are encouraged and welcome to apply through NCMAS and Pawsey Partner schemes, which will have, I believe, more resources available for all science areas, especially for the energy resources as well. On the next slides, just reminders about the timeline of submissions. So both calls are already open, and NCMAS call will close in the first week of October, and Pawsey Partner Merit Allocation Scheme will close in the second week of October, so 5th of October and 11th of October exactly. And then the applications will go through technical and scientific assessments with allocation committee meetings organized in first half of December, and allocations announced at the 21st and 22nd of December. And then the allocations will start from early 2022. A bit of discussion about GPU resources. We have mentioned that in 2022, you will be applying only for CPU time on Setonix. So what's happening with GPU partition? So GPU partition will firstly will be available from more or less second half of 2022. And when we've discussed this with chairs of both merit allocation schemes, we have proposed to organize access to this particular partition through a separate early science call that will be published and available in the first half of 2022. So please keep an eye on that. Those resources, so GPU resources of Setonix in 2022 won't be available in NCMAS and Pawsey Partner. So you will apply separately in the first half of 2022, and the announcements will be done by Pawsey. There is also one thing that you should know about the CPU partition of Setonix. We are preparing to have Setonix phase 1 installed in the last, or available in the last quarter of this year, or actually in the last month of this year. And for this short time, we wanted to already have a possibility for some of the researchers that are keen to spend time to adopt their codes and adopt their workflows for a new system, to have a possibility to access the system early. So there will be a call or expression of interest for current projects to actually use the Setonix CPU partition and try to migrate the codes and adapt the codes in later this year. So please also keep an eye on that. The last thing I wanted to mention is that in our preparation to support workflows and codes running on GPU partition of Setonix, Pawsey team has prepared a programming environment that supports AMD GPU porting, because as it was mentioned by Pascal, the AMD, so the GPU partition of Setonix will be based on AMD Instinct GPUs. So there is a bit of difference in terms of how you actually use programming tools for that particular GPU. But the programming environment actually is already, that kind of programming environment is already provided on Topaz. So if you are interested to experience how your code, GPU code, can transition to AMD GPUs, please contact us, and we can provide you with access to topaz where you can test your codes against HIP, which is a CUDA equivalent, and OpenMP, which is a well-known parallel programming model, which on Setonix will also support GPU codes and GPU offloading. So on the next couple of slides, I wanted to give you a little bit of information on how to apply, and that's both looking at the actual details of what kind of requests you will be putting into your applications in both NCMAS and Pawsey Partner for Setonix. Have a little bit of discussion of, I think a lot of researchers are asking the question how we can actually estimate the service units for a system that we don't have access to yet. Because I mean, benchmarking is an important part of estimating your service units usage for future. We wanted to provide a little bit of guidance for you, and I will prepare a couple of information there, and also some guidance on actually how your request should look like for 2022 allocations. And we will end with some additional information about where to apply. So actually a bit the discussion about the application portals. So looking at the resources available for NCMAS and Pawsey Partner in 2022, those resources are actually very, so the availability of those resources is related to how the system will be deployed. And we have mentioned that there will be Setonix phase 1 and Setonix phase 2 deployment. For that reason, and also again, that was consulted with the chairs of NCMAS and Pawsey Partner allocation committees, we have made a decision to ask you actually to put 2 requests. So the first request will be, let's say you can call it a Magnus scale request. That will be a request for the full year, and that request will be off scale of Magnus in terms of the number of service units provided to those schemes. As we have mentioned at the beginning, phase 1 system, phase 1 Setonix system was meant to be a computational replacement of Magnus and Galaxy resources in terms of computational capacity. Pawsey wanted to make sure that we'll be able to operate both Magnus Galaxy and Setonix phase 1 together. I mean, just to make sure that we can migrate all researchers and codes without issues to the new platform. For that reason, that the first request will be of Magnus scale. So the numbers are here. You in NCMAS, it's the total capacity of 100 million service units. For Pawsey Partner, 110 million service units. And then you will separately apply for Setonix phase 2, which will become available in the second half of 2022. The most important information here is that this allocation will be available pro rata. That means that from time when Setonix phase 2 will become available for researchers, your allocated compute time will be scaled pro rata for an allocation till the end of the calendar year. And you can see for this half a year, the total capacity is estimated as 150 million service units and 190 million service units for NCMAS and Pawsey Partner respectively. One important change here that I wanted to mention, and you will see that probably in future years, so probably starting from 2023 already, you will see that we will be increasing the minimum request size. And that's related, of course, to the amount of resources we are providing, but also it is related to the fact that we see that projects that are allocated with bigger allocations, they usually decide to run their simulations at scale and think of actually scaling their research to bigger number of nodes, amounts of data, or just the precision of their calculations. And this is something this is a kind of thing, and this is actually something that is driving us, because it's basically those kind of facilities like Pawsey should be supporting large scale compute. So you will see that the minimum request for future allocation schemes will also increase slightly with, and also the available resources will increase. We can move to the next slide. Here, just short two examples, what it actually means that your projects will be, so the second request will be available pro rata. So on the left-hand side, we have a scenario where your first request for, let's say, NCMAS in that case is 2 million service units, and the second request is 10 million service units. However, Setonix phase 2 is not available from the beginning of second half of 2022, but from the first day of the fourth quarter of 2022, due to, for instance, delays, which we hope won't happen. That means that your real allocation will be the guaranteed 2 million service units of your first request, Magnus scale, and then 5 million service units, so the pro rata equivalent for fourth quarter of 2022. And on the right-hand side, you have a, let's say, more positive example where you get access to all the allocation requested because phase 2 system becomes available from the beginning of second half of 2022. Let's move on to the next slide. And now just briefly discuss benchmarking and service unit estimation that we usually do when we submit applications to NCMAS or Pawsey Partner schemes. So benchmarking and scaling is a very important part of your application. So you demonstrate the efficient use of supercomputer. You actually show that you are able to run your science at scale, and you also show that you require access to facilities like Setonix or Gaudi. So ideally, those benchmarks and scaling should be prepared on the system you're applying for. Of course, I mean, in that case, in the case of Setonix, you don't have that opportunity, but yeah, I'll discuss on how you can mitigate that issue. On the right-hand side of that slide, you actually see the real-world example that we are using very often in our documentation, showing that looking at scalability is not the only thing we believe our researchers do, because you can clearly see here in the NWCAM example that the wall time is reducing with increased number of cores and nodes provided to the computational job. However, looking at the cost of node hours, you can clearly see that there is or that is basically related to service units. You can see that there is a sweet spot in around 1024 cores. So we believe that this will be the decision and driving the researchers. Basically, we want to make sure that we also optimize the usage of service units. So that would be the typical size of the job you will be running. And we are actually in Pawsey Partner forms and NCMAS application forms asking you to let us know about these kind of informations, right? So what are the typical number of nodes? What are the typical number of cores your jobs will be running on based on your experience on a specific platform? On the next slide, I will comment on how you actually can estimate that for Setonix. Setonix will not be available for benchmarking of codes and workflows for 2022 allocation requests. What we have seen is that service unit cost per simulation and comparison between Magnus and Setonix may actually vary, and may vary for various codes for different workflows as well. We have tested a couple of applications that we believe are one of the most popular packages that are being used on Magnus. And we have seen that an average increase of 20% in service unit cost per simulation. Right? However, it's very important to mention that, I mean, the service unit cost is one thing, but the other thing is that your actual computational throughput which will be substantially increased because for those cases, we have also seen the much shorter times to solutions per simulation was up to 3.7x speedups. We are aware that probably when you're planning your yearly usage of a supercomputer, you want to run a specific number of simulations. So for that reason, we actually recommend that your first request will be actually calculated based on Magnus service unit cost per simulation. And then just to make sure that, that in case your service unit cost is increased slightly based on that average 20% that we have mentioned here, we recommend you to add this 20% to your second service unit request, and also add additional capacity that you want to ask for within the second request. One important information here is that Setonix will allow overuse of your allocation with reduced priority. However, this overuse will be capped at 50%. That basically means that you will be able to use up to 150% of your allocated of your allocation. However, this last 50% was reduced priority as it was implemented at Pawsey Systems and Magnus for many years. On next slide, I will just give you some links and guidance about where you can get some more information about how to apply. For NCMAS, please visit the NCMAS application portal, so ncmas.nci.org.au. You will be able to apply for Setonix access through NCMAS application form, and the requests that for first and second your first and second request for Setonix will be visible as a separate fields there. There is also an information for applicants document there, so please look at it that will guide you on a couple of other decisions that you might have to make, and also it contains information about eligibility criteria. There is a slight change in Pawsey Partner scheme this year. We have moved the submission form to a tool called LinkLinks. That's a tool which is supporting many conferences, especially if you have ever participated in the biggest supercomputing conferences, ISC or SC. This is a tool that is being used for submissions and then review of papers for those conferences. When you go to the link provided here, you will find a sample submission form where you can just go and have a look at what information is required from you to submit. And then you can also create your account and submit a proposal through that portal. With that move, we have improved slightly user experience when you are submitting applications. I'll just mention one thing, which I think will be probably useful for most of you. With this new submission form, you can actually create a team that is submitting an application. So you have a lead CI and other CIs, so chief investigators of the application. And this group can collaborate on preparing and then submitting the application. So we'll have access to the submission form, and then we'll be able to update various parts of that submission form. With that, I think we will be just providing you with a couple of links and information to where to find more info about what is happening at Pawsey. So some standard links to our YouTube channels with a lot of useful training materials, user support portal. But also I'll mention on the top here, we have prepared a special page which describes all the important 5 changes that you will see for supercomputing services for 2022. If you have received the emails around the Pawsey Partner allocation scheme being open, you will find a link to that particular page there as well. And I think with that, we are going to the question session. Thank you.
Thank you, Mache. Feel free to put your questions in the chat, or you can also raise your hand, or you can unmute as well. We do have a couple of questions right off the bat. Can a single institution apply for both schemes? And if you're speaking, Mache, you're on. There you go.
Sorry, yes. So as a single institution can apply for both schemes. Then there is a, if you look at the specific eligibility criteria, you might see that there are discussions around how many applications a single group or a single PI or a single lead CI can put to a specific scheme. Actually, in the Pawsey Partner scheme, you will see that we will still operate something that we were operating in previous years, which is a top-up mechanism, which means that if you, as a Pawsey Partner institution, if you have applied to an NCMAS scheme and you were not awarded with the full request, then your application will be then forwarded to Pawsey Partner scheme and assessed there for additional top-up of your application. So I guess my recommendation would be that if to apply to NCMAS, and if you are consider applying to NCMAS if you are Pawsey Partner institution researcher, your unsuccessful, if hopefully that will not happen, but if your application will be unsuccessful or partially unsuccessful, that application still will be considered within Pawsey Partner scheme. One thing that you need to know is that one CI or lead CI cannot be awarded with two projects separately from NCMAS and Pawsey Partner. So in that case, we will be probably looking at providing you with a top-up of your NCMAS allocation rather than awarding you with both NCMAS and Pawsey Partner. But yeah, please follow the links to all the specifics of the schemes. This is nicely described there.
Thank you, Mache. And we did just post those links that appeared on that last slide into the chat. The presentation will also be emailed to you after we finish today, and the recording available next week. Following on the partner, there's a question around the Pawsey Partner scheme. I guess more of a comment, a question. They seem to be open to anyone. They do not seem to be open to anyone outside of WA. Is that true?
So if you follow the actual eligibility criteria there, the lead CI of the project, yes, that person must be affiliated with one of the Pawsey Partner institutions. So as I mentioned, so the four Western Australia universities, CSIRO, or Western Australia government institution that is doing research projects. But all of our projects that are, most of the projects that are being allocated through NCMAS and Pawsey Partner are actually a collaboration projects, and you can bring other researchers to those collaborations, not only from other states, but also from other countries. And we actually encourage you to do that. And especially now with this option where you can have a collaborative preparation of the application, that I believe takes it to a slightly different level as well. And I saw one another question about when do we put the requests or submit the request for phase 2 and phase 1 within the applications that you will be sending to NCMAS or Pawsey Partner, so this month or in the beginning of October. So basically you apply to both phase 1 and phase 2, so those both requests have to be put into your current applications to the calls that are currently open.
Thanks, Mache. My group has primarily used Topaz this year. Is it possible just to request time there, or do I need to submit a Pawsey Partner application for CPU time and then get Topaz access associated with that project?
So Topaz is currently, and for next year or so, will be available mainly for GPU migration purposes. And time on Topaz is not being allocated through NCMAS on Pawsey Partner. Although if your codes are already prepared to use GPU architectures, we do accept requests of moving part of the allocation to Topaz, as we did in previous years. We'll probably we'll do similar for the 2022 allocations. So yeah, I think really the answer here is that it will function as it was functioning for last year or so. We really think that Topaz will be a critical part of our infrastructure in terms of making sure that we can support multiple workflows and application software packages and prepare them for using AMD GPUs.
And there's quite a few questions coming in. So how and when would a current project with a Magnus allocation request access to Topaz for GPU migration?
I believe I have already answered that question. So you, through NCMAS and Pawsey Partner, you will only apply for CPU resources, and access to Topaz might be available for you as an additional access to make sure that you can migrate to GPU resources. But Topaz resources are not allocated through NCMAS or Pawsey Partner.
I'm not sure. I think you're looking at the chat as well. There's a number of messages around NUMA and NCMAS, so I'll let you reply.
I've answered the NUMA questions.
Okay.
There's a question about whether the GPU phase will be delayed because of in light of the worldwide CPU shortages, chip shortages. I'm not sure if I'm going to really come with a good answer. I don't know if Chris and Maciej feel like answering that question specifically about delays to phase 2.
So we did experience delays, but those delays were not actually related to the shortage of in terms of the CPU availabilities and parts availabilities. The most of those delays were in fact related to some COVID-related processes or issues, but not directly related to the technology availability.
If you have additional questions, feel free to put them in the chat. Otherwise, feel free to unmute.
I think you and May had a very good point that CSIRO is indeed nationwide. So CSIRO is a partner. So members of the eastern states of CSIRO can apply through the partner scheme.
Do we have any other questions coming in the chat, or feel free to unmute?
So there is a question about the exact models of CPUs and GPUs. So the CPUs will be AMD Milan CPUs. Each CPU will have 64 cores, and I don't remember the exact frequency numbers, but it's somewhere around 2.5 gigahertz per core. So for the And yeah, we do have the exact model numbers of those CPUs. I will be happy to share these offline if that's required. So that's Jacob's question. And in terms of GPUs, that's actually a bit more tricky because we are here talking about GPUs that currently do exist, but not a lot of information about those GPUs is available. So actually, when we have discussed the fact that you won't be able to apply for GPU resources through NCMAS and Pawsey Partner schemes, that was a bit related to how much information we can actually share about the new GPUs that will be used in Setonix. If you want to have a little bit of information about those GPUs, looking for something around MI Next might help you. So those are AMD MI100 is the current GPU, which was already available for evaluations and as well as for use in some institutions. I think for more than a year already. And that's this GPU that we have been using inside Pawsey to make sure that we are prepared to support codes for AMD GPU architectures. But the code name for the next GPU is currently still not officially known. So a lot of people refer to those GPUs as MI Next.
Okay, how about around storage? As part of the application process, specifying storage requirements, and should that be based on Acacia?
So I'll do my best to answer. So with Acacia, I mean, by default, a lot of projects get a certain amount of storage, and that will still be the process. There'll be a terabyte of storage. On Acacia, if you need a lot more, then of course you have to put in the storage requirements. Always do that. You may need a lot more. The main thing with Acacia versus, let's say, what we're doing now, which may be /group, is that there'll be definitely changes in how you interact with that storage. So that's a big thing about how you would maybe move data around. So before you'd have it in the file system, you could say, I'm going to save stuff to group. But remember, even prior in previous allocations, if you really were producing enormous amounts of storage, there would still need to be some data management where you would use that. If you needed to really have that data available for long-term purposes, you'd have to indicate that you're going to, maybe migrate to off-site storage, because Pawsey wasn't really providing, 10-year, 20-year archival storage. That was not the storage that was provided. So Acacia has a different setup and a different way you interact with it, but the storage requirements you could still list as being the same. You would just make sure that they would be, we need a storage on Acacia at the equivalent of 1.5 terabytes or 2 terabytes, because this is our setup, and we will also manage data by, possibly migrating to off-site storage, because then there is no indefinite storage provided by Pawsey. There's never been really like indefinite storage provided, not to that very long-term scale.
I would,
I don't know if,
I would add something here. So please have a look at the information that are being provided for both NCMAS and Pawsey Partner around the storage. So what Pascal mentioned is true. So you can, the default allocation on Acacia is 1 terabyte, but you can apply through NCMAS and Pawsey Partner for up to 10 terabytes of storage on Acacia. And then anything above that will need to be organized through or applied through a separate process related to managed storage allocations at Pawsey. So we believe that this 10 terabytes of storage per project is something that will accommodate the research of a lot of projects that we currently have allocated. And all those additional requests are something that you are probably thinking of storing at Pawsey for a longer time than just a calendar year availability for your project. And that's when you start to go and apply for something which we call managed storage allocation at Pawsey. And for the specific information about the storage allocations, have a look at information for applicants documented at CMAS portal. And with Pawsey Partner application form, we actually try to incorporate that information in each field of the application. So please have a detailed read of the instructions there. And if there is any, if there are any questions or something is unclear, please please send send a message to email to help@pawsey.org.au. There was one another question. I was also looking at other questions that are coming. I can see there was a question about whether similar top-up mechanisms are available for NCI. I don't know in details. I think for some cases there are those mechanisms, but you will need to check with your specific, I mean, with specific details for your institution. I think it might actually differ from institution to institution, but yeah, please do send. I would probably recommend this question to be sent to the NCMAS secretariat, and that will give you a bit more clarity. I think that the email there is ncmas@nci.org.au. Okay.
So there's another question further down asking, can researchers be successful in multiple applications if they're not PIs?
Yeah, so I can explain how it works for, I believe we have now a nice alignment between both NCMAS and Pawsey Partner. So we have lead CI and CIs in the project. Yeah. And so what you will see in the eligibility criteria is that lead CIs and CIs cannot be on two applications or cannot be awarded within two separate applications. However, with all the other members of the project, you can actually those other members can appear in multiple projects. So if you are a lead CI or CI, that means that you are contributing your experience, your research experience, your technical experience to that particular project, and we allow that to be contributed to only single project within Pawsey Partner and NCMAS.
I see Doug has a follow-up question on the storage, essentially the fact that we're going to have this object store Acacia system and whether that will impact recommended file formats. So by default for, let's say, larger computing systems, there is a sort of an underlying recommendation to try to best use the parallel file system, and certain file formats kind of lead into that. But in terms of Acacia, we are doing our best to provide documentation of how you would interact with it to sort of best use it without necessarily saying directly go into your codes and change file formats. So we're not necessarily saying that there's a recommendation just because of Acacia. There are certainly recommendations because of the parallel file system that you're going to be writing to, like Scratch, and the object store itself also best interacts with certain types of files. But if you need to, you don't have to necessarily, it doesn't mean that you're limited to only those file types. You can produce other file formats with it and interact with Scratch and interact with the object store. It's just there are recommendations for best performance, essentially. I hope that clears up. If you want any more details, I can go into a bit more offline.
And I can see a question about Zeus. Yes, Zeus will be decommissioned together with Magnus. And this is actually why we have made the decision to have Setonix nodes to allow node sharing on Setonix, right? So two or more jobs will be able to allocate resources within a single node on Setonix, just to make sure that we will be able to support all the workflows that are currently running at Pawsey.
And it's also, I guess, going to make workflows easier because everything will be running within the one system.
Great question so far. Any more questions, either in chat or unmuting? Okay, if not, we will be sending out the deck to everyone, the slide deck to everyone. Oh, one more, sure. Post it in the chat or unmute.
Yeah, feel free to unmute yourself as well.
queue limits and wall time.
Yes, so we have go through a configuration discussions. The 24-hour limit will remain, but as you know, we also have the long queue currently operating on Zeus. So I believe this is, correct me if I'm wrong, Chris, but I think this is also the plan for Setonix to have a long queue available.
For a modest number of nodes.
I don't know if Jacob, if you have, because there are many other things related to job configurations. Is there any other specific parameter? The question is around SU cost difference, you know.
No, we're pretty keen to have an SU actually be representative of the work being done, and we're keen to avoid charging different rates for the same thing, because when we do our reporting, we want to have an accurate picture of the amount of time that was actually consumed on the system.
I'm actually quite keen to also share a bit of information about how the SU cost will look for GPUs. This is something that we will make a communication about in future as well. I mean, closer to the availability of the GPU partition. Now it's not crucial because, as we mentioned, you are not applying for GPU resources within NCMAS and Pawsey Partner for 2022. However, you will see that there will be a SU cost equivalent that we will propose for GPU resources, and that will be actually energy-based, which will work in a way that when you will run your application, benchmark your application on CPU and GPU resources, and then compare your service units usage, it will actually give you the optimization of your service unit usage will actually give you an indication of the more energy efficient device that you can use for your science. So basically, by choosing the optimal service unit component or device within our infrastructure, you will be opting to use more energy efficient resources for your science. So we'll be linking that with the energy consumption. And again, we cannot share this information now because there are a lot of things that we cannot share about the newest GPU.
We'll get there. All right, any other questions? We will be sending out the PowerPoint deck and making the recording available as soon as possible. So if there are no further questions, just, yeah, here we go, one more.
So the question is around MPI implementation. Without MPI implementation, you can't use, can we some, okay. So without MPI implementation, I'll read it out. Without MPI implementation, we can't really use multi-node computation. Can we submit based on just OpenMP benchmark on a single node? So I would probably say that there are various requirements for various projects. Some of the projects will actually, and that's related to the shift that we see in how the large-scale resources are being used. Some of the projects will have requirements around extreme data processing challenges, right? And in these cases, you can basically see that sometimes the software that is being used is maybe locked to be used on a single node, but then a larger workflow is being built with some additional tools. I don't know, like Dask or some other tools that are available for workflows, Nextflow, for instance. And I believe and will be continuing to support such applications because obviously the success of such projects is dependent on access not only to supercomputers like Setonix, but also to large-scale, high-performance storage and file systems.
Can I add just to that, in case it's a question also about determining how things would run from a 24-core system, 24-core node, because you're limited to only 24 cores, so going up to 128 and figure out sort of how that might perform. I mean, the best you can do is you have your allocation, know how well it performs from going from 1 core to 2 cores to 8 cores to 24 cores. And then it's true that you can't just simply extrapolate, but you know, if you're trying to say, well, we're going to use one node, but we use all 128 cores, you know, a general extrapolation is not that bad an estimate just to figure out how much wall time something might run. It's a bit complicated to go past that point. If that's the focus of the question, then you're somewhat limited, and you do your best based on looking how the thing performs and knowing the bottleneck of the code and saying, okay, well, this is kind of how might scale and might plateau after some point.
All right. Thank you very much. Thank you all for joining today. And thank you to our speakers, Pascal, Chris, and Mache. Round of applause, virtual applause. And like I said, you'll be hearing more from us. So thanks very much.